Hello there, grade 12s. Welcome to the second lesson of functions. So today we are looking at your favorite topic, inverse functions. Right, so before I continue or start with the topic, I'd first like us to look at what is an inverse, right? Or the inverse of a function. So if you just check a simple Google definition, they'll tell you there that an inverse function is simply a function that reverses the result. So what does an inverse function do? It reverses the result of the original function. Right, okay. So others like to think of it as the mirror reflection, right? The mirror reflection of the original graph. Right. So today we'll be specifically dealing with an inverse function relating to a one-to-one function called a linear function. Right. Okay. So usually we know this type of a function as a straight line function, right? So that is the normal wording that we commonly used to, which is straight line function, right? Okay, so I just want us to get deep now into what an inverse linear function is, right? Okay, so I'd like us to consider a function, or I'd like us to consider the function f of x is equals to 2x minus 4, right? Okay, so if this is the function that we are considering here, okay, I'd like us to draw this inverse function or the sketch of this function, right? Okay, so how would we do that? So what is the most important thing when you are to sketch a graph? So those are some important skills that you need to acquire in grade 12. I know that at this point it's late, but at this point you must have at least have acquired the skill of drawing a sketch of a graph, right? Right, so let us have a sketch here. Right, so when you draw a sketch, having a ruler is not really that necessary, right? So I'm just trying to make my work neat here, so that's why I'm using this, right? So that is why. Okay, so the first thing that is important when you want to be drawing a sketch, right, that would be the x and y intercepts. So the intercepts are very important when you are to draw a sketch of a graph. Right, let us start with the y-intercept, right? What do you do when you want to find the y-intercept? You make or you let x to be equals to 0, right? Okay, so in this case here, you let x to be equals to 0. So that means that f of x or f at x will be equals to 2 into 0 minus 4, right? So immediately you can tell that this one will be equals to 0 and f at x will be equals to negative 4. Now that means that the coordinates of the y-intercept is what? It's 0 is to negative 4. So let's check, where can you find 0 is to negative 4 in the graph here? So 0 here, the negative 4, maybe somewhere there, right? Let us put the negative 4 here for argument's sake, okay, right? So that would be the y-intercept there, okay, right? Now we have found the y-intercept. Now let us go on to find the x-intercept. How would we find the x-intercept? So for the x-int, what do? You let y to be equals to 0, right? So that would be 0 is equals to 2x minus 4, right? Then 4 comes that side, this will be equals to 2x, and x, sorry about that, and x would be equals to 2, right? So that means the coordinates there is 2 is to 0. So we're expecting 2 is to 0 to be somewhat there, right? Okay, so you see that we are expecting the graph here to take this shape, right? So this is f here, so we're expecting it to take the shape there, right? Okay, so I hope that this made sense, right? So this is our linear function here. So even from the gradient here being positive, you can tell that this is an increasing function. Okay, now let us see, how do we then draw the inverse function? Okay, so the first step into drawing an inverse function. So the first thing that you should know is that we denote an inverse function using this symbol here, f and the power negative 1, then x. Right, okay. Then how do we find the inverse? The first thing is to change this f here to be y, right? So now we are trying to find the inverse, right? So how would we do that? So we would simply just say, all right, y is equals to 2x minus 4. That's the first step that we are to do when finding the inverse. So simply, the first step is just removing this and replacing it with a y instead, because we know that basically this represents the y values here, right? So that's what we're trying to do there. Then the second step now is to interchange x and y. So where there was x, you put a y, and where there was a y, you put an x, right? Okay, so that means this will be x is equals to 2y minus 4. Right, okay. So you see that now this can be a function because we have x is equals to 2y, or x is the subject of the formula. So usually we are used to y being the subject of the formula in a function, right? So we represent the set of outputs, right, in relation to the set of inputs. So now we need to say, okay, now we have this here. Let's make y to be the subject of the formula. So how do we do that? We need to take 4 to this side, right? So that means x plus 4 will be equals to 2y. So now we need to divide both sides by 2, right? So that means x plus 4 over 2 will be equals to y. Then now this is your inverse function. But now you need to write it in this form here. So that means that, oh, the inverse function here will be equals to what? X plus 4 all over 2. So if you want to simplify it, you can just say this is the same thing as x over 2 plus 4 over 2, which can also be written as 1 over 2 x plus 2, right? So please make sure that your answers are always in simplified form. Okay, right. So now we have the formula for the inverse function, right? So now we need to draw it on our Cartesian plane to see exactly how different is this inverse function, right? Okay, so the first thing again would be for us to find the x-intercept, is it? So I want us to see the workings here. I don't just want to feed you information without you seeing where it comes from, right? So let me quickly squeeze this here. I just hope you will see. So the first thing here would be to determine the x-intercept, right? So if our formula here for the inverse is f at negative 1, x is equals to 1 over 2 x plus 2, and we want to find the y-intercept. So what do we do when we want to find the y-int? We let x to be equals to 0, right? Okay, so where there's x, we put 0, right? So we let x to be equals to 0, sorry about that. So now it will mean that f at x, or f at negative 1, would be equals to 1 over 2 into 0 plus 2. Now that means that our y-intercept, or the inverse of the y-intercept, is equals to 2. So that means that now 2 would be the y-intercept. So it means 0 is to 2, which are the coordinates here. This will be 0 is to 2. That means we have somewhere there, we have a 2. Right. Okay. Make sure that you're following, guys. Please make sure that at any point that you feel like you are losing me or you're not understanding, please make sure you pause the video and you go back just to understand. So now we have the x, y-intercept. Now we need to find the x-int, right? So I won't write this here because I'm still using the same information. So in the x-int, you let y to be equals to 0, right? So where there's that there, you say 0 is equals to 1 over 2x plus 2, right? So you take 2, it comes that side, it becomes a negative 2 is equals to 1 over 2x. Now what do you want? You want x, so you can simply multiply by the reciprocal in both sides. So that will be times 2 over 1 on both sides, and that will be times 2 over 1. Sorry about that. Okay, so 2 over 1 times negative 2, that will be negative 4 is equals to what? To x. Right, so that means now the coordinates, it's negative 4 is to to 0, right? Because that is the x-intercept. So now let's go back and plot there. So negative 4 is to 0 will be found somewhere there. So we'd have a negative 4 is to 0 there. So you'd see that now we'd have a function like this here. Okay. Right. So let me make this my negative 4 here so that it's kind of neat, because I don't want it to be... Okay, so that's our negative 4 there. Perfect. Okay, right. So do you see that at some point these graphs will meet here, or they will cross each other at this point here? But before I get there, I want you to notice something here. Look for the y-intercept of the original graph. So this is, the purple one is f at negative 1, right? X. Then for the original one here, it's f, right? So there's something that I want you to notice here. So you see that the y-intercept here, which is negative 4, which is 0 to negative 4, is actually the x-intercept here, which is now negative 4 is to 0. And the x-intercept here for the original graph, which was 2 is to 0, is now 0 is to 2, which is now also the y-intercept of the inverse. So now what does that mean? It simply means that when we're dealing with inverse functions, you'll find that the y and the x values will interchange, right? So where there was an x, your x will now be a y, right? So the x and y values, they interchange, right? So I hope that, guys, makes sense and I'm not confusing you in any way, right? So look at this point here where the graphs intersect. So this is called the point of intersection. So for you to find the coordinates of this point, that would be you now equating the graphs. So, right, let me deal with that and let us find the point of intersection there. Right, let me now take this thing off. Right. So I want us now to find the point of intersection. Okay. So now let us check here. We said that the inverse was actually equals to 1 over 2x plus 2. And the original function, okay, fine, I've now messed that thing up there with the colors, but it's fine. I just hope you guys are following. So that is equals to 2x minus 4, right? Okay, so now we want to find the coordinates of this point of intersection there. So what we see is that at that point exactly, the graphs will share the same coordinates because they are touching. Thus, we are allowed to equate the graphs because we understand that at this point here, the graphs will also be equal. So we are allowed to say now at that point of intersection, f, or the inverse of x, will be equals to the original graph of x. So in other words, 1 over 2x plus 2 will be equals to 2x minus 4. Now, that comes that side there, or let us take the 1 over 2 to the other side, right? So we'll be left with 2 on this side, then 4 comes that side. This will be plus 4 is equals to, when 1 over 2 comes that side, it becomes a negative. So 2 minus a half, that would be 1 over half, which is 3 over 2x. Right, perfect. So that will be 6 is equals to 3 over 2x. Then now what do we want? We want x, so we can multiply both sides by the reciprocal, which is 2 over 3 times 2 over 3. Right, so this cancels out. So we have x on this side. So now that will be 6 times 2, which is 12, then over 3, which is 4, is equals to x. So now we have the x value of the point of intersection. So now what can we do here to find the y value? Because remember, we wanted the coordinates. So we can just take this x here and put it on any of these equations here. Because why? at this point there, both the x values and the y values are equal, right? Okay, so we can just use any of that there. So we can say that, okay, let me find the y value using this one here. So 2x is equals to 4. So what do I want? I want the y value. So f at 4 will be equals to 2 times 4 minus 4, right? So f at 4 will be equals to 2, which is 8 minus 4, and that will be 4. So we have a point of intersection of 4 is to 4. Now that will mean at that point there, we have coordinates, which is 4 is to 4. Right. So guys, that was the end, or that is the end of our inverse functions on one-to-one linear functions. I hope that this guys made a lot of sense and that you were following, right? So you join me next time for inverse functions on quadratic functions. Thank you.